Hi guys, and welcome to my talk. My name is Lukas Kosiński, and you probably have heard that a lot of times, but I'm going to say it once more. It's super nice to be offline in Berlin again for the Qt World Summit and see you all in person. Yeah, as you may guess from the title and from the agenda that you may have seen over the internet, I'm going to talk about using Qt on macOS platform. Some concepts, some things will be common with iOS, but we will mainly focus on Mac. Shortly about myself, I have a background as software engineer. Nowadays, I'm not coding that much. I have an experience on various platforms and wide range of Qt projects, including the ones for iOS and macOS platforms. After some years of coding, I started a Safe Studio QtQML consulting company. If you miss deadlines regularly, you can let me know. Usually, I don't wear a suit, but my guys ask me to do so because then I look smarter than I really am. Yeah, and for the last year, for the things that I do for the community, I got a title of Qt Champion. So, what are we going to talk about? The presentation, my talk, is going to consist of 3 elements. First, we are going to talk about how to interface C++ and Objective-C with dummy simple example. Sometimes when you code a Windows application, there is a need to connect to Win API. Sometimes if you develop Android application, you need to access some native Android features with Java. And exactly this need, but on Mac, we are going to address. Then, the things that you have to do after you are done with coding. To my mind, it is one of the most problematic things here. So we are going to talk about distribution of macOS apps. Then, like the things that you have to take care of if you plan to port your application to macOS, and I estimate the time of the presentation to take more or less 35 minutes, and then we will have some time for questions. So, before we start, I wanted to share some of my feelings about using Qt for macOS platform. Well, I bought my first Mac a few years ago, and after like 2 days, I wanted to throw it in the rubbish. The system is okay, but non-native Qt programming may be problematic sometimes. I don't really have any complaints about Qt on this platform. The problematic things here are related to Apple ecosystem and the fact that there are like regular often updates, and Qt as another tool has to stay up to date, and you may be a great Qt developer, but with no knowledge about Apple and all the distribution processes and like how the code signing and notarization works, yeah, it may be cumbersome to make your app available for the users. My personal record is 5 weeks to release an application via App Store. That's how long the review process took. Yeah, and I have to admit that a lot of those things were mysterious for me, and that was the main reason why it took time to develop some things. So I hope that with the information that you got after my talk, you would be armed to do things faster. So maybe before we start, I just wanted to ask who here has a Qt application running on macOS? Okay, who enjoyed the process?
Which part of the process?
Like, not code sign, because that's enjoyable usually. So, I personally expected less people with actual experience here, but still, let's go with the first announced element of the presentation, which is C++ and Objective-C. I'm going to give you a simple example how to call some Objective-C from from C++ Qt code. So that's how a typical Objective-C function may look like. Well, once upon a time, I have been doing some Objective-C stuff, and one of my colleagues saw me doing this, and he asked how you can do that for like this long and don't throw up. There are things that are in the syntax that typical C++ developers don't like. However, we have to live with that. Objective-C went in a bit different direction than normal plain C++, so we have to deal with that. It's not Objective-C course. So, why do we actually need to call Objective-C from time to time? Well, first of all, you need access to native API to get some native features done. And nowadays, the Swift is like primary language for new Mac and iOS apps. However, still Objective-C API and Swift API, the support for the features is kept more or less the same. Another need is the thing that some dependencies may be available only in those in Objective-C, and you may want to use it. And believe me or not, but sometimes I had the cases that customers had already Objective-C application that was like working, and there were really not many things to fix there, but they wanted a new UI, and they wanted to leverage the Qt features that they have, but still reuse the code that they have been developing for years. So they had a slightly different process. So those may be the reasons. Now let's take a look at the simple example that we are going to have. So I just made a simple QML application. Here is the button in the middle, and once I push it, there should be this kind of window asking me to like authorize using the fingerprint option that is native here. I was just looking for like an example that we would not see in other platforms using like the commonly available Qt API, so that may be an example. The architecture is going to be more or less like that. We have a QML frontend. It doesn't matter what we have here. I have a Qt C++ class exposed or registered to QML, so I can call my request touch ID method from QML. And I actually made this simple, quite dummy, so I do not return any value what happened. I just request touch ID, and I forget whether it was successful or not. Yes, and here I have the source file. I can freely mix C++, plain C++ and Objective-C code in the source file, but it has to have like extension, which indicates that it's like Objective-C file. And here I use some kind of a popular pattern for Qt programming, which is opaque pointer. It has a forward declaration in the header, but it has an implementation in the source file. And this function here calls this function here, and it calls the native implementation that is actually done in Objective-C. So before we start, we have to have XCode installed on our machine, because it goes with all the necessary tools that you would need, like the API, like all the assigning tools and so on. So you for sure need that before you start. And the code. Here we have simple C++ header, nothing fancy here. This is the opaque pointer that I've declared here. Here is the source file, and we have the implementation of C++ class/interface here. This is the method. I mean, it was the code that you have seen previously, so I wrapped it because it's not Objective-C course. It basically I think that I found it. I asked ChatGPT to do so, so there's no point to display it here because it would be messy then. Yes, and in my private class, I keep the Objective-C implementation as the member. I have to initialize and free the memory here using the Objective-C syntax, and I call it just like this. I think that I don't have to like show how the main public class calls request touch ID because that would be simple. Yeah, and that's basically it. I mean, this code makes this happen, and I don't need to do anything else. Of course, if I would like to actually react to a particular situation, whether the authorization was cancelled, rejected, or so on, I could make this request touch ID method returning some enumeration, maybe in a pair with some string error message or so on. Yes, but it's just to show you an example. Yes, so that's how the simple example of C++ and Objective-C interaction may look like. Now, the things that you have to do since you are done with coding, that is the most problematic part, I would say. So, basically, there are two ways to distribute macOS apps. The first one is using the App Store, and here you may benefit from the things that App Store does for you. So you can use analytics, you can implement the purchasing subscriptions and so on using the interface that they have, and you don't need to like implement payment gates or so on. However, the problem here is the review process, which may be problematic. Apple, real human, has to go over your app and see whether it's scam or not. And you have to share the revenue with Apple, and it does not matter. You may have like the licensing and stuff outside of the Apple payment, and you are anyway supposed to share the revenue with them. So the alternative is to provide the users with your own channel. It may be some website or some installer or whatever, a place that where you would share the disk image or an installer of your application. However, here, if you care about the features that App Store has, like analytics, feedback, opinions, purchases, and so on, you would need to implement that on your own. And you have to do some extra stuff to like make users trust your application. We'll talk about that later. And of course, you have to maintain the infrastructure that would allow the user to download your app at any time. So, firstly, you would need an Apple developer program. Well, theoretically, you could go without that, but then you would not be able to code sign or notarize your application, and users would get like serious security warnings. Hey, are you sure that you want to open this app? So that's why you would want to get Apple developer program. It's paid. I think that last time we paid for that, it was like $100 per year. So yeah, but for like the serious commercial projects, it should not be an issue. Yeah, and you need that because with that you would not get access to that Apple iCloud, iCloud purchases, notification features. You would not code sign and notarize your app, so you need that. After you set up the account, you have to go to Apple website, set up an identifier for your app and so-called provisioning profile. And to distribute the application, you would need to get a certificate. For macOS development, there are two that are interesting for us. The one is called Developer ID application. It may be used to sign an application or the application disk image with .mh. DMH format. The second one is if you go with PKG. I will explain the difference between installers and disk images a bit later. Yeah, and let's assume that you have your app ready and you don't have like any features that you have to port or anything other regarding coding. You would need to prepare this kind of XML information property list file, which basically specifies things like the versioning, identifiers, the executable of your app, copyrights, permissions, and application icon, and so on. You can use variables here, which would be passed from CMake, if you use CMake for as project build system, and you specify the point to information property list. For example, in this way, by pointing the path to the file to this variable here for the target. Yes, and there are a bunch of already existing properties that you may pass, but you may also want to set up your own variables in CMake and pass them to information property list. So it's not an issue here. Yes, and how does the distribution process look like? I mean, firstly, you have to make sure that your application works outside of your IDE, outside of your development environment. So you have to make sure that all the dependencies of the cool stuff are inside the application bundle. So for that, you may want to use macdeployQt tool and O tool. They basically put QML stuff and Qt libraries in the frameworks linked with your application. Then you need to code sign your application, including the certificate that you have to set up on Apple website. And sometimes you may want to include entitlements. Entitlements are the specification of the things that your application is capable of doing. You need to provide that. macdeploy has extra parameter for code signing, but it's limited. So that's why you may either code sign your application using macdeployQt or using code sign. But if you have entitlements or if you want to pass some extra parameters to code sign tool, which you get with XCode installation, then you may want to call just this tool, not macdeployQt. Then you have to pack your application either to disk image or the installer. What's the difference here? To put it simply, installer is more like a proper executable that you run. There is licensing, that are things that you may want to adjust regarding what gets installed. And disk image is more about actual volume, and you just drag and drop your applications bundle from the disk image to your system applications folder. It's not like one way is better than other. It's just the matter of the preference. For App Store, you would need an installer. Yeah, and after you are done, you should notarize your application. For that, you also need that certificate that we set up earlier. And for that, you would need to use xcrunaltool command from the Xcode. You may wonder what's the difference between code signing and notarization. Why do we need to do both of those things? Well, code signing is more like making sure that you are an author of the application and nobody has tampered with the code, with the application since you signed that. Notarization is different. It's like you submit an online ticket for Apple to automatically check your application for malicious software. And then it takes some time, depending on how big your application is. And and you don't really get like the notification. I wrote some scripts that were like pulling information about my notarization status, and the script was working until I got like the result, whether it was successful or not. Yeah, and after notarization is done, then you have to like put a stample, and your application disk image package installer should be ready to release. I didn't put like the exact comments in the presentation because it depends from app to app. Yeah, and now the things that you should think about while porting the app from Windows or Linux, any other desktop platform to Mac. Here I was supposed to ask the question who considers to do that, but it looks like most of you already have Mac app. So I probably don't need to convince you that if you do that, if you get another platform supported, you get a wider audience. I put here some statistics that like globally, 20% of desktop systems are Mac. So 20% is at the same time it's not that much, but it's significant. In the States, it's even bigger. We can see like the tendency that Windows is going down and Mac is going up. I had a customer, and they, for like 10 years, they were developing a serious medical application for Windows, and they told me, Lukas, we don't need Mac because our software is so expensive that we ship it with a Windows tablet. So yeah, but after some time they also changed their minds because there would be cases where the user would think, why do I need like extra stuff to just use this single application? So they also port to Windows, to Mac after some time. Yeah, another case is that you just would like to keep the brand consistency if your application is more like a consumer facing. And you may want to leverage the ecosystem. There are statistics that say that Apple devices, Apple consumers are more willing to pay for the licenses or for the single in-app purchases or so on. So you may want to like leverage that fact and use those purchases that are there, the notifications that are there, and so on. So here are the things that I listed for making sure that you are not stuck with the development of your app. Well, first of all, you have to verify whether all the Qt modules that you use are supported on your platform. I don't find many differences between Linux and Mac. In fact, there are cases where particular module is not supported on Apple ecosystem. For example, well, it's the case for iOS, but for some time, Qt NFC was not supported on iOS. You have to prepare the dependencies because, like serious apps, they often like include some third-party stuff, and the authors of that projects, it's possible that they didn't think about like making their library working on Apple. So you either have to look for alternative, or if it's open source, contribute to make it working. Naturally, you may want to update all the native codes that you have. If you call to some native Windows or Linux features, you need to do a replacement of that stuff for Mac. I can recommend a software development pattern called Factory. It provides an abstraction layer, so from the UI, from the other parts of the code base, it does not matter what system it is. OpenGL, it works, but it's kind of obsolete on macOS platforms. They use Metal as the graphics rendering system. So if you want to make sure that your fancy graphic stuff would work, you may want to consider using a SceneGraph or nowadays render hardware interface from Qt that provides this abstraction layer, and it simply works. OpenSSL, Apple has a version for that. There may be some differences, so you may want to address that. And of course, the differences with the file system. I mean, it may be simple, but for example, as macOS is Unix-based system, right? For example, you have to remember that on Windows, decays doesn't matter, while on Unix systems does. Yeah, and you cannot forget about like two important phases, because you come up to the do phase to actually doing that. You have to evaluate whether it actually makes sense for your application to be ported, because maybe if only few people are going to use it, and it may not make business sense to do it. It may be expensive. It takes time. It depends on how big your application is. Then don't forget to have a plan for that, to prepare like the serious timeline in which you want to achieve and release the app and estimate all the features, and then there is a time for actual execution of the process. The thing that I can recommend is also that you should constantly make sure that your app works, for example, by leveraging the CI/CD system. I had a case where, for some reason, the app was not released on Mac for like 4 years, and because there was no CI/CD, the Windows version was working all the time, but after we had to like make sure that a Mac version works again, then we had problem, and such a problem would be fixed, would be solved if there will be a proper CI/CD, constantly checking whether the app still builds, and so on. I have no idea what exact issues you may have during the porting of the app to macOS, because some of the things, they are quite unique to your app, and it's always a surprise. Yeah, just to remind you, think about it makes a business case, whether you have skills and manpower. You can let me know if you need help in this matter. And I think that it was my last slide. Yes, thanks a lot.